Hello, my name is Balázs Pataki from HUN-REN SZTAKI, and I would like to give you a quick overview of the operation of the HUN-REN ARP Research Data Repository of Hungary. I will show you how we extended the functionality of Dataverse by adding metadata schema authoring via CEDAR's drag-and-drop user interface, and how we extended metadata authoring via RO-Crate using our own AROMA tool, which allows describing datasets and files in more detail. So in this demo, I will show you three things. First, how you can easily extend an existing Dataverse metadata block or create new ones using our ARP Schema Registry, which is based on CEDAR. Then I will show you how you can also RO-Crate using AROMA and add your own metadata schemas to describe your dataset or files in even more detail. Finally, I will introduce the ARP search tool, which allows looking up datasets and files by either Dataverse metadata or your own RO-Crate specific metadata. So we start working with ARP using Dataverse. This is our research data repository, and assume that I am a paleontologist who wants to share his dataset with the world via ARP. For this, I have to go to Dataverse and create a new dataset. So in Dataverse, there are some fields that has to be provided because these are requirements, like the title of the dataset. In my case, it will be called Interesting Dinosaurs, because you will see these are very interesting dinosaurs indeed. I can also provide a Hungarian title because in our installation, we already added a Hungarian title field to support the Hungarian researchers. We also have to provide a description. For now, it will be very simple. And we also require to add a subject property. As we don't have paleontology in the list, I will just add other for now. With this, we already set the citation metadata required initially by Dataverse, and now we can go to the most important part to add our files to the dataset. I have this dataset of various images of very interesting dinosaurs that I want to describe in this dataset. So once I uploaded the files, I can save the dataset, and the initial version of the dataset and its metadata is available. You can see here are the files that we uploaded. We can take a look at this and see that these are actually the files that we are interested in. You can see the structure of the files as was available in my zip file originally, and you can see the initial set of citation metadata that we already filled. Now, if I go to add some more metadata, then you can see that in the citation metadata, some new fields appeared right away. But we have some other metadata schemas or called metadata blocks in Dataverse that we can fill out, like we can have add some geospatial metadata if we like, or some journal metadata where this data set has been published, for example. Now we are interested in the citation metadata because I just realized that it has a lot of properties, but it doesn't have one where I can describe how the data was anonymized. And maybe it will be important for me in the future. So to solve this, in ARP, we have the ARP Schema Registry, which can be used to extend and create new metadata schemas. If I go a little bit back here, then you can see that we have all the Dataverse schemas stored in the ARP Schema Registry, and you can access it by browsing and selecting this in the editor. This is CEDAR's editor, where you can see for each property you can define various things, some requirements, and things like that, whether it's multiplied or required and things like that. So in the citation metadata, I would like to have a new field at the end. So I will add a text field because I want to define data anonymization. I have to define a label for this as well. and I can save it. Well, we have a validation error because CEDAR says that a term URI is required. So in our system, for every field, you have to define a semantic URI to identify your property. This can come from BioPortal, which is integrated with CEDAR. So if you have a field that matches that name in one of the ontologies, then you can use that as the URI provider. Or in our case, we just enter a dummy URI for now. This will be enough for us. So we can now save this. It is green, now it is saved and validated, and we can now export this dataset, this schema to Dataverse. So once I press export to Dataverse, I have this green box saying that it has been exported. So if I go back to my interesting dinosaurs dataset and reload it and go to the metadata authoring, I hopefully see in the citation metadata block a new field I just added. And yes, there it is, data anonymization. And I can describe that we didn't apply any kind of anonymization to this dataset this time. I can save it, and I can see that among the other citation metadata fields, this one appeared as well with the value I provided. If I go here, I can see that we forgot to set the help text, but that's not a problem. We can go back to the ARP Schema Registry, go to the data anonymization field, and provide a help. How data was anonymized. 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 Right. If we save it, and again, press to export to Dataverse, it will be synchronized to Dataverse again. And if I reload the dataset and go to the help box, now it is our new text that we just added. So this is the way you can extend an existing metadata schema using ARP and the ARP Schema Registry. Now I go back to my interesting dinosaurs dataset, and I want to add some more metadata. So looking at the metadata blocks, I can see that unfortunately no paleontology related metadata block exists in Dataverse. So in real life, we would require uh, researchers of a given discipline like paleontology to come together and define the metadata schemas that their discipline requires. So this would be a bigger effort than I just present here. But for now, I will be all the paleontologist of Hungary, and I will decide what metadata block we need. So I think we need one that describes what branch of paleontology a data set relates to. So as we don't have this already available in Dataverse, I can go to the schema registry again and try to create a new metadata schema this time. So I go to the Dataverse folder. Here I have to create a new folder for my new metadata schema. This will be called paleontology metadata. And here in its folder, I will create a new template. The schemas are called templates in CEDAR. We have to provide a name, an identifier, and with this, I can just save it. So for the sake of this demo, I will just want to add a simple one single field. So as you can see, I can select various types for the fields like text or date time, email, and things like that. For this field, I will choose to add a radio choice. So this will be called paleontology branch. I will also need this for the label. Here we started the small letters. And yeah, what kind of branches can we define here? Like it could be vertebrate kind of animals, or invertebrate. Or maybe it's paleobotany, let's say. So I will have these three things to choose from. So if I save it, of course, I will have a validation error because I need a term URI. So I go back here, I fix the label as well, and add a URI just with this dummy domain we have. Now I can save it. So once it is saved and validated, I can export it to Dataverse just as I did with the citation metadata block earlier. So this has been exported. If I go back to authoring my dataset, if I reload it, then and start to edit the metadata, then our new paleontology metadata block has just appeared. So I can go here and define that actually my data set is about vertebrate animals. So I can save it and go back to see my metadata. And as you can see, besides citation metadata, this paleontology metadata block just appeared with the value I just said before. So this is how one research discipline and a group of researchers can come together and define their own metadata blocks using the ARP Schema Registry. So our dataset is now sufficiently annotated, but what about our files? If we go to our dataset and go to the Files tab, you can see here all the files that we have. And as you can see, the file names themselves are not really descriptive. Of course, I'm a paleontologist, so I know that this is Tyrannosaurus rex. But if we take a look at the metadata that is provided by Dataverse, you can see that there's just very minimal set of properties that can be defined here, like the hash of the file, the size of the file, or the type. You can add some more, like free text description, or you can add some tags and some other values. So as I would like to describe some more details of my files, like what is the type of the dinosaurs, or what geological period it lived in, or on what continent, well, how could I do this? I could add a description here in free text form, or I could just prepare some JSON and paste it here, or some XML. So somehow it doesn't feel right to describe some structured metadata in this field alone. Instead of this, we came up with the idea to add first-class support for RO-Crate. RO-Crate is a format that makes it possible to describe metadata in any depth and in practically in any format. So what we have for each dataset, as you can see, we have this AROMA tab. If I click on it, the AROMA RO-Crate Manager opens, and I open it in a bigger window. So what you can see here is actually the same data that we had in dataset. In the dataset view, you can see each of the files that we uploaded. You can see the same structure, and you can navigate in the directories and select other files in those directories. At the dataset level, you can see the same set of data that we had in Dataverse. Instead of metadata blocks, we have these tabs here. And if I go, for example, to the citation tag, then you can see here the title that we specified, or if you go to the paleontology metadata block that we have created earlier, you can see our setting here. So RO-Crate itself is a JSON linked data format, and it's very flexible and very easy to author and interpret, especially if we have a visual editor like AROMA. So AROMA and Dataverse are connected and are synchronized in both ways. To demonstrate this, I will open them in two separate windows. I will have AROMA here and Dataverse on the other side. So if I go to AROMA, to the citation metadata, and I update the title here saying that this is edited in AROMA, and I save this. This is synchronized back to Dataverse, and if I click the window of Dataverse, it will reload itself, and you can see the new value of the title field right away. And the synchronization works the other way around. So I go back to Dataverse and edit it here and say this is edited in Dataverse. And when I click Save Changes here, you will see right away that the title will update in AROMA. So I click Save Changes here, and boom, we have interesting dinosaurs in Dataverse written in AROMA. So you can see that all the data that is in Dataverse can be edited in AROMA and vice versa, especially for the Dataverse related data. But in AROMA, we can do more. And to demonstrate this, I will go back to AROMA and to our file. So in AROMA, we have this block here called metadata schemas. What it does is that it allows us to browse the ARP Schema Registry that you've seen before. And we can even use the Dataverse, the previously defined Dataverse metadata blocks, as metadata for our files. For example, I can select the geospatial metadata, add it to our Dino 11 JPEG, and we have now here a new tab where I can define a geospatial data similar to what we have in Dataverse. So I could add here like a new one called Chapel Hill. And I can add some more details. This was the name I added to this element. This is the city. It is in the United States, if I'm correct, and it's in North Carolina. So once we edit it and save it, this will be associated with our file. Of course, if we go back to Dataverse and take a look at the metadata of Dino 11 JPEG, we won't be able to see the values that we just added because this is only seen at the RO-Crate and AROMA level. But if I go to the AROMA tab, you can see all the metadata of the file, including our newly added Chapel Hill location. But we can do some more. We have two sets of metadata schemas in CEDAR. One of those which are related to Dataverse and are used as metadata blocks in Dataverse. And we have the so-called file schemas. In case of file schemas, it is more relaxed and users can create their own schemas in every way they want and as many as they want to describe their own data sets or their own specific files. For example, here we have this predefined image metadata that I can add because I have an image here, although this is more about how this image was captured using a camera and when was it and what exposure was used. This is not relevant in our case, but we could have this if we wanted. But as we don't want this, I can remove this from our data set. But as I mentioned, as a paleontologist, I would like to add some more data to each of my files, like the dino type, the geological period, or the continent that this animal lived. To do this, again, we have to go back to the ARP Schema Registry. So here I will now define a file schema, go to this folder, and create a new template. And this will be simply the dino metadata. We have to provide the identifier, and I can now save it. And I would like to add, first of all, a field to describe the dino type. We have to provide the label, as usual, and we have to provide the URI, which will be, again, our dummy domain. And we can save this. Now I want to have a geological period. Again, I think I will use a radio choice to make it easier for the users. So this will be the geo period. we add the URI as always. Have to add a label. And we have to provide the options. So I know about the Jurassic period and the Triassic and also maybe the Cretaceous. Right. Now we have the two fields, and I would like to add a third one and demonstrate how CEDAR integrates with BioPortal. In this case, I will add a continent field, and I want to provide, and I want the BioPortal ontology to provide the values that can be selected for this field. So I will have this continent field with a label and a URI as usual. And now the values I would like to add from an ontology. So I go back here to the BioPortal search facilities. And yeah, I can see if I search for continents, I find the RCD ontology, and this one seems just right for me. If I can see here some data about it, and I can see the details and the actual classes and where it is located and what values it provides. So it has Asia, Europe, and North America, and this just looks fine. So I will use this and add to my continent field. So what we did here is we defined a field which will provide values from a predefined ontology or a branch of this ontology. So I can just now save it and go back to AROMA to actually use our Dino metadata schema. So here I am in AROMA. Add the metadata schema. I can browse the CEDAR schemas just before. I select the Dino metadata, and boom, we have this new tab here, and we can define the values that we just wanted. So I'm a very much trained paleontologist, so I know that this is a Tyrannosaurus Rex. And although we know this from the Jurassic Park movies, it actually lived in the Cretaceous times, and it lived in North America as provided in this controlled vocabulary list. So once it's all set and I save it, all this Dino data is associated with my file. Of course, this is only available at the RO-Crate level, which I can prove by going to Dataverse. And if I try to look up Tyrannosaurus Rex, it won't find my data set because this is not a data that is stored by Dataverse, but it is stored by ARP. But then how can we search for files based on this metadata? So for this, we have our own search engine called ARP Federated Search. And this is based on a knowledge graph. And in this knowledge graph, we collect all the data that is available in the system of ARP. For example, we have all the schemas that we created so far, like the image metadata and the citation metadata. We have all the datasets that are available in ARP, and you can browse and view all the metadata here, just as it is available in Dataverse, or you can actually navigate to the actual dataset via its persistent identifier. Now if we go here and try to look up Tyrannosaurus Rex, we won't find it because this is has yet not been published from Dataverse. So we go back to Dataverse, go back to our interesting dinosaurs in Dataverse and publish it. Once we publish it, it will be available for a bigger audience, not just those who are logged in and have access to our Dataverse, but it will be available for outside researchers who can then download this dataset and work with this dataset. So our dataset with interesting dinosaurs has been published, and now it should be available in our ARP search service, and let's go there and see if we can find our very interesting dinosaur. So if you go here, you can see that we have one additional data set harvested, and hopefully this is the one where we have the file annotated with Tyrannosaurus Rex. And yes, indeed, it found Dino 11 JPEG. And if we go there, then we can see all the metadata that we added previously. And we have the persistent identifier via which we can actually access this file in Dataverse. And here we could download it, this specific file, or if we are interested, we can download the whole dataset as well. So let's do that. We can download all the files zipped together. When we download it via Dataverse's download function, then we will just receive the files zipped together, but you can browse here all the files that you are interested in. In Dataverse, you have to go to the Metadata tab and export the metadata separately in whatever format you like. And this is, for example, Dataverse's JSON, native JSON format. Or if you like, you can download it now as an RO-Crate package. And in case of RO-Crate, it will contain all the files and the RO-Crate metadata added to the crate. So here are the files as usual. And we have here the RO-Crate metadata that we authored in AROMA. This contains all the Dataverse metadata and the additional file metadata we added. We also provide a nice preview, a simple preview mechanism, so that you can browse the dataset and the RO-Crate data. You can check even the schemas that we used, or you can go to a specific file like our Dino 11 JPEG, and you can see that actually here we have all the metadata that we added in AROMA.